Today we're going to do matrix arithmetic. So we're going to learn how to add, subtract, and multiply a matrix by a scalar. The scalar is just a number, and that's on the outside of the matrix. And then what we do is we multiply everything inside the matrix by this number, by this scalar. An equal matrix, or matrices that are equal, means they have the same order, and not only that, they are basically identical. So the numbers are in the same spot, same numbers in the same spot. So these two are exactly the same. 1, 2, 3, 4, 1, 2, 3, 4. They are identical matrices. Elements, the elements are these numbers in the matrix. They are exactly the same in the same spot. Well, these two matrices are not identical. They have different numbers in different spots. Adding and subtracting matrices. Now, before we can add or subtract them, they must have the same order, and then we can add or subtract them. So here we've got a 2 by 2 matrix, that's matrix A. We've got a 2 by 2 matrix, that's matrix B. 2 rows, 2 columns for both of them. So A plus B, this is going to be 9 minus 2, 4, 7 plus minus 2, 5, 3, 0. And we add, because it's plus, we add elements that are in the same position. So we will be adding the 9 and the negative 2. Then we'll be adding the negative 2 and the 5. And keep going like that. So the 9 plus negative 2 is really 9 minus 2, which is 7. Minus 2 plus 5 gives me 3. The 4 plus the 3, because they're in the same spots, gives me 7. And 7 plus 0. 7 plus 0 is 7. If we take away, we do exactly the same thing. This is B, says matrix B first, minus matrix A. 9 minus 2, 4, and 7. Again, we subtract matrices that are in the same spot. So we're going to do minus 2 minus the 9. The 5 minus the negative 2. So we have to be careful when we've got the negatives. So the first one, minus 2 minus 9, is going to give me minus 11. 5 minus negative 2 is actually going to be 5 plus 2, so it's going to give me 7. The 3 minus the 4. 3 minus 4, negative 1, and 0 minus 7 is negative 7. You can do that on your calculator, but it's not really necessary to do. A scalar, remember what I said to you, a scalar is like multiplying by a number 1, and it just sits on the outside. So example 2 here, I've got m and n, and part A says 4m, so 4 times the m. Matrix m is 3, 2, 1, 5, negative 1, 0. So I'm going to times everything inside this matrix by number 4. So 4 3s, 12, 4 5s, 20, 4 2s, 8. 4 times negative 1 is negative 4. 4 times positive 1 is 4. 4 times 0 is 0. Part B, we've got the half. We're going to do the half first. So I'm going to times the half by everything in there. So half of 2 is 1. A half of 3, I'm going to leave us 3 on 2. I can write 1 and a half, but we try and leave it in fractions. 4 divided by 2 is 2, and negative 6 divided by 2 is negative 3. Now I am going to add that. You've got to keep using your bod maths. Okay, the times was first. Now that I add that, I get 1 plus negative 4. 1 plus negative 4, 1 minus 4, negative 3. 1 and a half plus 3 is 4 and a half. 4 and a half is 9 divided by 2. 2 plus negative 2, 2 minus 2, 0. And minus 3 plus 2 is negative 1. Again, as I said, you can just type all that into your calculator and still get it. The zero matrix, as the name suggests, every element, all of them are 0. Every single one of them. Example 3 is a show that question. It says there's G, there's H, show that 3G minus 2H equals 0. With the show that question, we always start with the side that we can work on. So left-hand side, 3G minus 2H. So it's 3, 6, 0, negative 4, 2, that's my G. Minus 2, and my H is 9, 0, negative 6, 3. And I know my answer, it's going to be 0, but I need to show all the working out. So I'm going to times this matrix by 3. 6 3 is 18, 0, negative 12, and 6, minus, I'm going to times this matrix by 2, 9 2s are 18, 0, minus 12, and 6. And now I'm going to subtract the 2, and I get 0, 0, 0, and 0, which equals the right-hand side as required. Make sure, because it's a show that question, we have to show that that's the answer that we're getting. Example 4. The sales data for 2 used car dealers, Honest Joe's and Super Deals, are displayed below. Construct 2 matrices A and B which represent the sales data for 2014 and 2015. Well, there we can see 2014, there we can see 2015 and the car sales for the 2. So really, there's our matrices. Okay, I've got to write A is 2014 because it says we've got to write them separately and respectively. So A is 24, 32, 32, 34, 11, and 9. And B equals 26, 35, 38, 41, 16, and 12. So there's part A. Part B, construct a new matrix C, which equals A plus B. Okay, so what does this matrix represent? Well, let's do it first, A plus B. So we're adding the two matrices together, 24, 32, 11, 32, 34, and 9, plus 26, 38, 16, 35, 41, and 12. Remember, we add the same positions together. So when I do this, 24 plus 26 gives me 50. It's 70, 27, 65, 67, 75, and 21. What does this represent? Now, if we look at it, we are adding 2014, because this was the 2014, and this was the 2015. We're adding up 2014 and 2015 sales for the two dealers. So that's what it represents. So represents, right matrix C, represents total sales for 2014 and 2015 for two dealers. Because that's what we're doing there. Part C, construct new matrix D, which is B minus A. So D equals B minus A. What does this represent? So let's do it. So 26, 38, 16, 35, 41, and 12. That's B. And A, 24, 32, 32, 34, 11, and 9. Taking away the 2, I get 2, 6, and 5, 3, 7, and 3. And what does this represent? Well, really, it's the difference between 2014 and 2015. So it's the increase in sales. Increase in sales from 2014 to 2015 for the two dealers. That's what it is. It's the increase in sales for them. Part D says both dealers want to increase their 2015 sales by 50% by 2016. Construct a new matrix B, which is 1.5 times B. Explain why this matrix represents the planned sales figures for 2015. So E equals 1.5 times matrix B. So 1.5 times B, which is 26, 38, 16, 35, 41, and 12. So when I do this, 1.5 times everything, I get 39, 57, and 24. And then I got 52.5. I get 61.5. And I get 18. Explain why this represents the planned sales figures is because by multiplying 2015 year by a scalar of 1.5 has the effect effect, not affect, has the effect of increasing each value by 50%, which is what we wanted. Almost 50% per year, I should write, per year, just to be exact. I did say to you I'd show you how to do things on the calculator. So if I go to the calculator, and I'll just do a real quick one. Here's where we get our matrix from. This is a 2 by 2 here. This is a row, column, and this one here, you can choose any one you want. So I'm just going to do a 2 by 2. 1, 2, 3, 4. Okay, that's a simple, easy one. I am going to matrix and do the transpose because I showed you to do the transpose. And remember, the transpose makes the row into a column. There it is there. I can add matrices very quickly. So I'll just do one here. 1, 2, 3, 4, and I will